And then if we look at the measured values when we do estimations, okay, we have to actually understand what's the units they are using and how are they corrected to. So if we look at the question here, the length of a square is measured as 8 cm, which is corrected to cms. So actually they are giving us readings that are in cms only. So 8 cm, the next one would be 9 cm, and the one previous to 8 cm was actually 7 cm. So actually we need to think of it as a ruler that has only got cms on them. Okay, so even though the measurements was in between those readings, we will round it to the nearest reading. So actually what you have to understand is there is a halfway point on both sides. So anything beyond this line we will measure as 8 cm, and any numbers before this line we also measure at 8 cm. So actually there is a error we create, because anything that's 7.5 we will actually read as 8 cm. So that's the maximum absolute error. Okay, so maximum absolute error will be 8 minus 7.5, which is 0.5 cm. And it's also 0.5 cm the other way as well. So it's both sides 0.5 cm. So where do you actually get this data? Is just reading what is it corrected nearest to. So just look at this, okay? It's always half the value of that give us here. So cm means 1 cm, and half of cm is 0.5 cm. So 0.5 cm to the lower end, we have 7.5, and 0.5 cm on the upper end, we have 8.5. So this is called the 7.5 is called the lower limit, and 8.5 is called the upper limit. Okay, so you will notice that actually 8.5 should belong to 9 when you round it off, right? So rounding off, so we have to actually understand that the value of 8 cm actually has a range of between 7.5 and 8.5. It can equal or being larger than 7.5, but it needs to be less than 8.5, because 8.5, as I said, it should belong to 9. So therefore there is no equal sign on the larger side. Okay, so by looking at just this theory, we know that these are not correct. So B and D won't be the correct answers because they don't make sense in according to our rules for upper limit and lower limit. Now we are finding the area. Okay, so area, and it's a square, so it's a length times a length. So actually it's because 7.5 is the lower limit, we have to square it, so it's length times length, which is length square, and then the upper limit again 8.5 times 8.5, we will get the upper limit done. So you can just get the calculation and should be able to get the answer, and the answer should be C. Okay, and then the same will be applied to number 7 and number 8. So the lower limit and the upper limits, so 3.5 and 4.5. Why? Because it's corrected to the nearest cm. So we are just converting that measurement, which is 0.5. So 0.5 less than 4 is 3.5, and 0.5 less more than 4 is 4.5. And similarly, the length of that rectangle, we will have 4.5 and 5.5 as the upper and lower limits. So the lower limit times the lower limit of the length and width will give you the lower limit of the area. So 3.5 times 4.5. Again, using the same principle that it can be equal to the lower limit but not the upper limit, we will use the upper limit. I'll use a different color. So these two. So 4.5 times 5.5 will be the upper limit. So you can do the calculation there as well. Okay, so that would be when we want to do any measured values errors for maximum absolute error, and then looking for the lower limit and the upper limits. And the other type that you will also come across is using the same principle, but now we are putting in a little more effort into the thinking of it. So they have a bag of salt which is measured as 1 kg corrected to the nearest kg. Again, kg, so half of that okay, so half of this is half times 1 kg, which is 0.5. So we have the lower limit of 0.5 kg and the upper limit of 1.5 kg. Then similarly, because we want the packs of salt to be packed in each packet, which is 6 grams corrected to nearest gram. Again, half of 1 gram is 0.5 gram. So the lower limit 5.5 gram and 6.5 gram is achieved. Now, if you read further, they want the greatest possible values of the packets of salt we make. So we want as many packets. So that means for the 1 kg value, we should take the upper limit as our reading because we want as many. So we will then use the 1.5 kg instead of the 1 kg reading they gave us because there's an error in our reading. So it's upper limit. And for the upper limit, we need to times it by 1,000 to convert it actually into grams, because 1 kg is equal to 1,000 grams. The word kilo itself means 1,000. Okay, so that would be 1,500 grams. And since it's 1,500 grams, we want to divide them into smaller packets. And because we want the value to be as big as possible, so that means we should put as little salt in each bag so that we can make more bags of them. So actually we should use the lower limit when we divide that, so that we know that we are putting in only 5.5 grams of salt in each of them. Okay, and then in here you will do the calculation, you will get that as your answer. So we can actually make at maximum of 272.72. Now this is a maximum value. Okay, so if you look at it as a number line point of view, it needs to be less than or equal to that value. So since the unit, we need packets, so packet is a whole number. So there's a 272 on this side and there's a 273 on this side. However, because we are talking about this region only, therefore we can only make 272 packets. Okay, do not just blindly round it off. Okay, even though it's a number they can round off to 273. It's just basically because that the 0.7 at the 0.72 at the back doesn't meet the requirement of having it as 5.5 grams. Okay, it would be less than that. So it's less basically like the leftover salt after you pack them up. It's too little to be making up a full packet, so that would not be counted. So it's actually just 272. And then you do the same for the others.